Assalamualaikum warahmatullahi wabarakatuh, and today I'll be presenting my electrical technology lab assignment. And my name is Sophia binti Hafizan. Nice to meet you, and I am a student of 54F5422300041. And I will be presenting job sheet 1. I am a student conducting an assignment video for my electrical technology subject at Mara Japan Industrial Institute. So my name is Sophia Fahima. You may call me Sophia, you may call me Fahima. And then I'll be explaining the objective of this assignment. So firstly, I have to determine phase angle and series RC circuits. And also I have to measure and calculate voltage drops in series RC circuits. And also I calculate impedance and phase angle for a series of RC circuits. And I will be recording the results in my workbook, which have been already sent out to my sensei, in other words, my lecturer. So the next part, equipments. Some of the equipments that I have used is the 1.2 AC circuit module, and I've used signal generator, and also use oscilloscope to check the phase voltage, and I'll also be using digital multimeter to see the voltage and current from the signal gen we use for the frequency. Then another one is shorting links and connecting links for our AC module. Then for the next part, I will be explaining the procedure and setup instruction. So first step is I will be inserting shorting links to circuit 1, which is circuit 1 shown in the figure. And then step 2, set up the oscilloscope as follows, which is time-based 250 micro per division AC single trace operation. You can find that on the button on the oscilloscope, and YFB channel 1 Y amplifier gain to 0.5 volt per division DC input, and also position channel 1 center at the screen of the oscilloscope, of course. And for the step 3, I will be connect channel 1 of the oscilloscope to the 1.2 AC model. The circuit should form as in this figure, so we will connect it to our channel 1 using the wire given to the oscilloscope. And then for step 5, set signal generator for sinusoidal output frequency 1 kHz and adjust amplitude control so that the multimeter indication is 0.1 volt. Then for the step 6, record the peak-to-peak voltage trace of oscilloscope, how many division, peak-to-peak value, and peak value. This was recorded in my workbook and sent to my lecturer. For step 7, set the oscilloscope channel 1 control to 2 volt per division and adjust the signal to output amplitude for multimeter indications of 2 volt and then 4 volt. For each setting, note the peak voltage value of oscilloscope trace. And then for step 8, set the oscilloscope channel 1 control to 2 volt per division and set the signal generator output amplitude for a trace of 12 volt peak to peak. And also record the multimeter reading our workbook. Then for my step 9, set the channel 1 control 2 volt per division and set the signal generator as shown in this picture, output for 3 volt as indicated by the multimeter, note the oscilloscope trace. And then for step 10, set the signal generator output amplitude for a trace of 12 V peak to peak, 6 divisions peak to peak. Note the multimeter indication of the waveform set for sinusoidal, triangular, square waveform, adjusting the output amplitude as necessary to maintain a trace of 12 volt peak to peak for each waveform in workbook. And then below, the next slide we will be showing the simulation of me doing my assignment.
First, we will insert shorting links to circuit 1 as shown in the figure. So this is the circuit 1, and then as you can see, the circuit connected such as from the figure. Then the step 2 is we will set up the oscilloscope as follows. Time base 250 250 microsecond per division, and it is AC. So this one we are setting it to so we will get 0.5 volt or 500 millivolt, and then for the time base we will use 250 millisecond. Right. So we have completed that, and also we will connect channel 1 of the oscilloscope to second. So this is the channel 1. We will connect it to 1.17 as you can see here. And then hence the circuit formed in the figure will be shown as this one. And then for step 5, we will set the signal generator to 1 kHz such as shown here. It is set to 1 kHz, and we have controlled the multimeter to be as 1 volt such as set here. Step number 8, the peak to peak value is 3 volt as you can see. Now we will record for 2 volt per division and adjust the signal generator output amplitude for multimeter to 2 volt. So now we have adjusted it to 2 volt, and then we will get the value of the peak to peak value is 6.3. Hence the oscilloscope peak to peak values will be 3 volt. We will adjust to the signal generator to find it for 4 volt.
Next, set the oscilloscope channel 1 control to 2 volt division and set the signal generator output amplitude to for a trace of 12 peak volt peak to peak, and record the multimeter reading in your workbook. Here we need to adjust the volt so that it will be 12 volt peak to peak, and then we take the multimeter reading and
So the next step, we will be recording the 2 volt per division and set the signal generator output for 3 volt. So the signal generator output is 3 volt, and then as indicated by the multimeter, note the peak value of the oscilloscope traced in your workbook. So the what was it? So the peak value of the oscilloscope, it is 8.8 volt. So the peak value will be 8.8 volt divided by 2. It will be 4.4 volt. Last step, we will need to find the voltmeter reading for sinusoidal waveform, rectangular form, square form, and also triangular form. And the value will be as follows.
As for the conclusion, in an RC circuit, the voltage and current exhibit a phase difference due to charging and discharging of the capacitor. When subjected to a sinusoidal input voltage, the voltage across the capacitor lags behind the input voltage during charging and leads during discharging. This phase shift is crucial for understanding circuit behavior, especially in AC circuits. Engineers manipulate this relationship to optimize circuit performance. These are the pictures I've taken during my lab for this assignment. Thank you so much for listening to my presentation, and I hope you have a very nice day. Thank you.